Okay, we're going to now talk about complex numbers in trigonometric form. So just in case you don't remember complex numbers, let's do a quick review from algebra. So complex numbers are all about if you have a negative number under a square root. A lot of times when you were in algebra class and you ever ended up with a negative under the square root, you would just say no solution. Sometimes you'd have this symbol, or you would say not a real number. And a lot of times you would just stop the problem. But then, if you recall, at some point they decided instead of just stopping and saying there's no solution, they did this thing where they broke this up into -9 is 9 times -1, and then they broke this up into two separate square roots, and then what they did is they introduced this thing called the imaginary unit, which is indicated by the letter I. So then the square root of 9 is 3. Square root of -1 is I. So now we say the square root of 9 is 3I. And this is called a complex number. So I'm sure you remember that. Maybe you had square root of -8. Well, if you simplify it, square root of 8 is 2 times the square root of 2. But then because of the negative, you also have an I. So it's also important at some point to remember I times I. Anytime you multiply two identical square roots, you just end up with what's inside. So then we also have this important fact that I squared equals -1. And the last part to review is in algebra, you were given, this is called the quadratic equation. You're asked to solve it. In this case, we're going to set equal to 0, so we're going to solve this equation. This doesn't factor, so what we had to do was use the quadratic formula. If you remember, quadratic formula is ax squared. So a would be like 1, b would be 2, c would be 2. And then you had that quadratic formula. If you recall, it's -b plus or minus square root of b squared minus 4ac over 2a. So this is how to get the solutions to this equation. So if I plugged in my a, b, and c, so b is 2, so -2 plus or minus b squared, so it's 2 squared, minus 4 times a, which is 1, times c, which is 2, all over 2a, which is 2 times 1. So now if we simplified this, have -2 plus or minus 4 minus 4 times 1 times 2 is 8. So 4 minus 8 is -4. Now before we started using complex numbers, you'd probably stop and you'd say there's no solution. Or nowadays we could say there's no real solution. But with complex numbers, we can now express this as minus 2 plus or minus 2I over 2. And normally, if you remember complex numbers, they always like to write them into two parts, what they call the real part and the imaginary part. So I'm going to break this up into two fractions, minus 2 over 2 plus or minus 2 over 2I, which simplifies down to minus 1 plus or minus I. So this is the real part, and this is imaginary part. So this is also a complex number. A lot of times we say, when they ask for the answer and the answer is a complex number, they'll say they'll want it in this form, which means they want the real part and they want the imaginary part in two different terms. All right, quick review of complex numbers. Now what's going to happen, since this is a trigonometry class, something they do is, another use of trigonometry is like an alternate way to express a complex number. All right, so let me sort of describe what that means. In trigonometry, we like to call complex numbers z, and here's how I'm going to express it. Z equals x plus yi. So for example, here's a complex number. Now this form a lot of times they call this rectangular form. Sometimes they call it standard form. And it's just the normal way we learn to write complex numbers. The real part plus the imaginary part. The real part is always just a real number. The imaginary part has this I here. Now what they decided to do is, first thing they decided to do was they decided they want to create some graphs. They want to graph complex numbers. So what we're going to do is we're going to graph complex numbers. So normally when we graph, the horizontal axis is your x-axis, the vertical axis is your y-axis, and you can graph ordered pairs, right? Like if I were to graph 2, 3, I would go, I'm not going to actually graph it here, but I would show you if I were to graph it where it would be, right? x2, y3, and that would be the point 2, 3. Well, here's what they decided to do. They decided they wanted to be able to graph complex numbers. So what they did, instead of calling this the x-axis, they call this the real axis. And instead of calling this the y-axis, the imaginary axis. So the idea is, here's a complex number, 4 plus 3i. Here's the real part, and there's the imaginary part. So what we're going to do is, I'm going to go to 4 on the real axis, which is like what we used to call the x-axis, and then go to 3 on the vertical, or now we call it the imaginary axis. So 1, 2, 3, 4, 1, 2, 3. This point right here, we would call that, it's the complex number 4 plus 3i. Say I wanted to do -1 plus 2i. Say I wanted to plot this complex number. Well, the real part's -1, so I go to -1 on my, what I used to call my x-axis, my real axis. then positive 2 on the imaginary. So this point, now I say, is negative 1 plus 2i in this complex plane. So sometimes we call this a complex plane. It's like a complex graph. Let's do one more. How about negative 3 minus 4i. So the real part is negative 3, the imaginary part's negative 4. So just about in here should be 3 minus 4i. So that's the first thing we do with these complex numbers. We actually graph them, and you'll have a couple of problems in homework where you'll be asked to graph some complex numbers. Not very difficult. But the more interesting thing now is we want to take a complex number and we call rectangular form, and I want to convert it or rewrite it into what we're going to call the trigonometric form. So here's where the trig enters in, and this is why we talk about this in trig class. So let me write out what the trigonometric form looks like, and then we can go from there. So it's going to have r, and then you have cosine theta plus I sine theta. So here we go from x and y, which these are going to be numbers. Matter of fact, in a minute, here's the problem I'm going to do. I'm going to take this complex number, 4 plus 4i, and I want to rewrite this complex number in what we call the trigonometric form. Now, the trigonometric form has r, and the other thing it has is theta. Now, the reason we call it trigonometric form is because look what we have. We have a cosine and a sine, right? Those are trig functions. And the I is here with the sine. Just like we have the imaginary part here, it's like there's the imaginary part in the trigonometric form. So what I really need to do is, in a minute, we're going to take this problem and convert it into the trigonometric form. And then also, we'll go the other way. We'll do a problem where you're given a complex number in trigonometric form, and then we will figure out how to convert it back to what we call rectangular form. So the key is, over here, it's like we have x's and y's, which are going to be numbers, and over here, we have r and theta. So it's almost like the key to converting back and forth is how do x and y relate to r and theta. Now here's a little heads up which may help you, because just right before this we did polar coordinates, if I can spell. And if you remember polar coordinates, we went back and forth between rectangular and polar coordinates, right? Well, you know what's interesting? If you go back, I'll show you in a minute, how I'm going to define r and theta are exactly the same way as we define them with polar coordinates. So it's almost like you're doing the same kind of thing. So let me just show that to you, and then we'll do these problems, and hopefully you won't find this too difficult. So let's define here is complex number in rectangular form, x plus yi, and I want to rewrite it in what we call trigonometric form. R times, in parentheses, cosine theta plus I times sine theta. So, if I want to determine R, you know what R is going to be? The square root of x squared plus y squared. If you look back at your notes for polar coordinates, that's the same exact definition that we had for polar coordinates. So let's just go ahead and work out a problem. That problem I gave you a minute ago was z equals 4 plus 4i. So then here's my x and here's my y. R square root my x squared, 4 squared plus my y squared is 4 squared. So this is 16 plus 16. Now if I simplify that, 16 times 2, a 4 comes out. So I've determined R is 4 square root of 2. And I won't give this background, but this goes back to actually, it's the same idea of when we started using vectors and polar coordinates and now complex numbers. They're all the same. If you go back and look at all three of these, you'll see this where R is the square root of the x part. With vectors, we call this the I part and the j part. With polar coordinates and complex numbers, we call this x and y. They're all the same thing. And the R, you just do the calculation and you're good to go. But now we also need to know, so for the trigonometric form, we need to know R and we need to know theta. Theta is used twice. And no big surprise here, if you go back and look at your notes for both vectors and polar coordinates, theta is going to be the inverse tangent of y over x. Exactly the same thing as we've done before. Now in those cases, once again, finding the angle sometimes takes a little extra work and you got to think about it. And that's because we're looking at inverse tangent. So you have to be careful what you're doing here. Matter of fact, the thing I always recommend, if I'm going to, in this case, I'm trying to convert this complex number in rectangular form to polar coordinates, I'm going to go ahead, and it takes about 15 seconds to do a quick sketch of this point. So 1, 2, 3, 4, 1, 2, 3, 4. So right there should be 4 plus 4i. The reason I do that is because here is r, here's theta. When I go calculate my angle, I know my angle needs to be in the first quadrant for this problem. So this one's pretty straightforward. So if I want to find the angle here, inverse tangent, my y is 4, my x is 4, so this is inverse tangent of 1. So we know inverse tangents, we ask ourselves the question, let's go find an angle. and this, in fact, is a special angle, so I don't need to grab my calculator. I can just do this with my unit circle. What's the angle where the tangent's 1? Or you can say where the sine over the cosine is 1, or the same thing. And we've done this enough that by now, in radians, we would say, we know at pi over 4 in that first quadrant, the tangent of pi over 4 is 1. So the inverse tangent is pi over 4, and since I'm in the first quadrant, so now I know r and theta. So I can now say in trigonometric form, so I'm going to now plug into this formula, r is 4 square root of 2 cosine of pi over 4 plus I times the sine of pi over 4. So that is now this complex number, 4 plus 4i, written in trigonometric form is this. I mean, this looks a lot messier, but you're going to see in a few minutes where there's some things we want to do in math that having a complex number in trigonometric form makes it a little bit easier. Now, in the homework, something they like to do is when they write this, you notice the theta here is the same. Sometimes, and this is not my favorite thing, but because it's in the book, you need to know it. They do a little shortcut where they write the r, and instead of writing cosine I sine theta, they do this thing where they call it cis theta. Cis theta means cosine theta plus I sine theta. They're trying to just, I guess, allow you a way to not having to keep writing cosine plus I sine theta. I don't mind doing this, but because the homework in the book requires this, then we need to be aware of it. So it's this one, and that shortcut form would be 4 square root of 2 cis pi over 4. So I think this is the kind of answer that the book we're using will look for. All right, not too bad. Let's maybe do one more, and maybe we'll do one where it's, well, let's do this. Let's go ahead and instead of doing another one, let's go the opposite way. In other words, let's now go, let's take a complex number in trigonometric form, and let's convert it to rectangular form. And this one you're going to really like. So here is a complex number written in trigonometric form. We'll call it z equals 10 times the cosine of 2 pi over 3 plus I times the sine of 2 pi over 3. And I want to convert this rectangular form, which is going to be like x plus yi. So I need to figure out what x is and what y is. Well, this you're going to like a lot. All you do is, it's like you multiply out the parentheses. 10 times the cosine of 2 pi over 3 is going to be my x. And then 10 times the sine of 2 pi over 3 is going to be my y. So it's almost like I just distribute the 10 inside these parentheses, and then I will have my complex number in rectangular form. And 2 pi over 3 is a special angle. So it's 10 times cosine of 2 pi over 3 plus 10 times I sine 2 pi over 3. And if you go to your unit circle and you look at cosine 2 pi over 3, it's negative 1/2. And sine of 2 pi over 3 is square root of 3 over 2. So you keep doing this. 10 times 1/2 is negative 5. So 10 over 2 is 5. So I bring the numbers up front. And this would be the rectangular form of this complex number in trigonometric form. So this is really not very hard. You just multiply out the parentheses. All right, now there's one more thing that we're going to do now that we understand how to write complex numbers in the trigonometric form. Sometimes with complex numbers, they want to do some math with complex numbers. So for instance, I'm going to call my first complex number Z1, and I'm going to call R1, and then inside the parenthesis, the normal trigonometric form, except everything has a 1. So this is like my first complex number. And now I'm going to have a second complex number, and it's going to look the same, except instead of all these subscripts of 1, I'm going to put subscript 2. So here's like my second complex number. Now they're going to do two things. What they're going to do is now, there are times where they want to multiply two complex numbers. Now you could go ahead and multiply the two complex numbers in rectangular form, and sometimes it's not too bad, but sometimes trying to do that in rectangular form starts to get very messy. So in other words, here is going to be like a little formula. If you're multiplying two complex numbers in rectangular form, and I'm not going to show you how this is done, but I'm just going to give you the formula. What ends up happening is you just multiply R1 times R2, and then inside parentheses, you have the cosine theta 1 minus theta 2 plus I times the sine, plus the sine of theta 1 plus theta 2. So it's almost like if you have, well, it's not almost like it, it's exactly like it. If you're multiplying two complex numbers, you multiply the r's, and then you take the two angles and you add them together, and that's what goes inside the cosine and inside the sine. So what's going to happen is, and then there's a second thing they have you do. They'll have you to divide two complex numbers. Now the formula for dividing complex numbers is you take R1 divided by R2, and then for the cosine, you take theta 1 minus theta 2 plus I sine theta 1 minus theta 2. So when you multiply two complex numbers, you multiply the r's and you add the angles. When you're dividing two complex numbers, you divide the r's and you subtract the angles. And just so you know, I haven't shown you this, but for your homework and on the exam, there's this whole section now called complex numbers. And basically everything I've shown you is on here. Here's a rectangular complex number. Here is it written in trigonometric form, and I even wrote here the shortcut form. So how do you get r? There's the formula for r. And here's how you get theta. So that what I just discussed now is if you have two complex numbers written in trigonometric form, if you multiply them, this is the formula. If you divide them, this becomes the formula. So what we're going to do, so our final problem here is, we're going to take two complex numbers in rectangular form, and we want to multiply and divide them in trigonometric form. So what's going to happen is, the first thing I'm going to have to do is convert the numbers. In other words, my first trigonometric number in rectangular form, so z1 is -1 plus I. z2 is going to be 1 plus I. Now I want to multiply and divide these two complex numbers, but I want to do it as in polar form. So the first thing I need to do is convert this first vector, z1, into polar form. I mean into, trigonometric form. And I want to convert the second vector also into trigonometric form. Well, right, the r is going to be -1 squared plus, there's a 1 in front of the I, 1 squared. -1 squared is 1 plus 1 squared, 1 plus 1. Looks like r1 is square root of 2. Now just to be safe, I'm going to plot this complex number. So it's -1, 1. So it's in the second quadrant. Because when I find my angle, I want to make sure my angle's correct. Matter of fact, let's do it now. And you know what? Because it's in the second quadrant, I have to be careful. So it's y over x. Y is 1, x is -1. So I'm really looking at inverse tangent of -1. So I know inverse tangent of -1 has to be where the sine and the cosine are the same, except one of them is plus and one is minus. Well, it's pretty obvious. My complex number is here in quadrant 2. So I know that the cosine is negative, the sine is, and where are they the same? They're the same at pi over 4. Sorry. It's in quadrant 2. 3 pi over 4, right? This angle right here, 3 pi over 4. Hopefully at this point, it's almost like a common sense thing that you know the angle is 3 pi over 4. Therefore, now, z1 is r cosine of 3 pi over 4 plus I sine of 3 pi over 4. So I've now converted this first complex number in rectangular coordinates into trigonometric. Need to do the same thing for my second complex number. So the r, 1 squared plus 1 squared, it's also square root of 2. Now this one, if I plot that complex number, I'm in quadrant 1. So when I go find my angle, So y over x inverse tangent of 1. So basically I say, you know, what's the angle where the tangent is 1 in this first quadrant? And it's pi over 4. So therefore, this second complex number is my r square root of 2. My angle is pi over 4 plus I times sine pi over 4. So once again, I'm given two complex numbers. I want to multiply the two numbers and then also divide them. But I want to do the multiplication and division with the complex numbers in trigonometric form. So I took my first complex number, rewrote it in trigonometric form, took my second complex number, rewrote it in trigonometric form. So now, to multiply them, what do? You multiply the two r's. Square root of 2, square root of 2. And then you take the cosine, you add the angles. 3 pi over 4 plus pi over 4 plus I, and the sine is the same thing. You add the two angles together. 3 pi over 4 plus pi over 4. So once again, multiplying the two vectors, if they're in trigonometric form, means multiplying the r's, and then you add the two angles, and that's what goes inside the cosine and the sine. So now I just simplify it, right? Square root of 2 times square root of 2 is 2. 3 pi over 4 plus pi over 4 is actually pi. So both these end up being pi. Cosine of pi is -1. The sine of pi is actually 0. So in this case, it's interesting, when I multiply these two complex numbers together, it actually ends up being a real number, which happens sometimes. The complex part goes away. So now I want to also take these two vectors and divide them. So when you divide, you take the r of the first vector, divide by r of the second vector, and your angles become the first angle minus the second angle. So let's just write that out. So r1 over r2 cosine of the first angle is 3 pi over 4 minus the second angle pi over 4 plus I sine of the first angle minus the second angle. Right, so I'm just using this formula way up here. So now if I simplify this, well, this is just 1. So 3 pi over 4 minus pi over 4 is 2 pi over 4, which is really pi over 2. So these are both pi over 2. So the cosine of pi over 2 is 0. And the sine of pi over 2 is 1. So as it turns out, when you divide these two complex numbers, it ends up just being I. All right. So that's pretty much what we're doing with complex numbers in our trigonometry class. Just a quick review. We can plot complex numbers. That was pretty easy to understand, plotting complex numbers. And then we learned how to convert back and forth between rectangular, a complex number rectangular form, and a trigonometric form. And the last thing we did was we learned how to multiply and divide two complex numbers when they are in trigonometric form. All right, hopefully you will not find this too difficult when you do your homework.